Okay, example number 3. You notice this looks a lot like the previous examples, except we've got this squared in there. So let's see what happens with that. A lot of it's going to stay exactly the same as before. Keep in mind what happens. We don't want a 0 in the denominator. The only way to get 0 in the denominator is if x equals -2 plus -2 plus 2 is 0. Squared is still 0. So x can't be -2. So I draw my asymptote there at x equals -2. Also, a fraction with a variable in the denominator and a constant in the numerator is going to go to 0, get really close to it, but never touch it. It's going to get close to 0 plus 4. 0 plus 4 is 4. So it's going to be like this at y equals 4. That's the horizontal asymptote. Now we just figure out what happens with this. So let's take a quick look. Remember what happens when things are squared. Something squared is always going to be positive. So in other words, if we plug in something just to the right or left of -2, so if we go to the right 1 unit from 2, I'm only going to go up 1. So the point is going to be right there at -1, 5. And if I go to the left 1 from that center point, I'm still only going to go up 1, because if I plug in -3, let's see what happens. Y equals 1 over -3 plus 2 squared plus 4. That's going to be 1 over -1 squared plus 4. -1 squared is still 1, so it's 1 plus 4, which is still going to be 5. So the point is still going to be up here at -3, 5. So when you've got that squared in the denominator, all that means is that both sides of the graph are pointing up. So we can analyze our graph now. Our domain, as usual, is all real numbers except for -2. We can't get down to -2. So x is not -2. The range here, I could say x is not equal to -4. I'm sorry, y is not equal to 4, but then we could say y equals 0, but we can't go below the 4 line. So the range here, because everything's above that, is y is bigger than 4. The asymptotes we've got, y equals 4, x equals -2. The y-intercept, let's find that real quick. The y-intercept, plug in 0 for x. Y equals 1 over 0 plus 2 squared plus 4. So y equals 1 over 2 squared is 4 plus 4. So it's going to be 4 plus 0.25. A fourth is 0.25, so it's 4.25. So 0, 4 1/4 or 4.25 is the y-intercept. The end behavior does the same thing. That horizontal asymptote tells us where our graph is going as x gets really big. So we're at these 2 arrows. As x goes to infinity, y is going to 4. And as x goes to -infinity on the left, y is still going to 4. And the behavior near the asymptote, because both sides are going up, on the right we're going up and on the left we're going up, we don't need to write 2 different statements. We can just write one statement. As x gets close to -2 from the left and from the right, so we don't need to worry about it. As x gets close to -2, y gets close to infinity. So that's how we deal with it when there's a squared in the denominator. You end up with both halves of the graph going in the same direction. That changes the range a little bit. It's not a not equals to, it's a greater than. And it changes how we write the behavior of the asymptote. Since it's going in one direction, we only need to write one statement. That's it for that one. We'll do example 4 on the next video.